Welcome. Today, we're diving into the world of Grade 5 math with Sadlier Oxford. We'll explore how to make math not just understandable, but truly enjoyable. Get ready to master key concepts and build confidence, all while having some fun along the way. Let's get started. Today, we're setting out on a math journey that covers some big ideas. We'll start with place value and large numbers, the foundation for understanding any number system. Then we'll master multiplication and division, the tools that help us solve real problems. Next, we'll explore decimals, how to read, write, and work with them. Fractions come after, showing us how parts make up a whole. Finally, we'll dive into geometry and measurement, where shapes and sizes come to life. Let's get started. Let's dive into the heart of our number system, the base 10 system. Every step to the left means a place value 10 times bigger than the one before it. Move to the right, and each digit becomes 1/10 of the previous spot. It's all about position. A 5 in the hundreds place isn't the same as a 5 in the ones place. Its value changes completely. This is the power of place value, and it's the foundation for everything we'll explore next. When we look at numbers, we can express them in different ways, each one showing the value in a unique form. Expanded form breaks the number down, stretching it out to highlight the value of each digit. Word form writes the number exactly as we say it, using words instead of digits. And standard form is the way we usually write numbers, just digits, compact and clear. These three forms help us understand numbers from different angles. Let's break down multiplying 2-digit and 3-digit whole numbers. First, we multiply the top number by the ones digit of the bottom number. Next, we add a crucial placeholder 0 before multiplying by the tens digit. This keeps everything lined up correctly. Finally, we multiply by the tens digit and add all the partial products together. This step-by-step approach helps us master multiplication with confidence. Let's break down long division into a simple, memorable process. We start with R, repeat or write down what's left over. Then B, bring down the next digit from the dividend. Next, S, subtract the product from the current part of the dividend. M means multiply the divisor by the new quotient digit. Finally, D, divide to see how many times the divisor fits into the current number. To keep it all straight, remember, does macaroni smell bad raw? Context is everything when it comes to remainders. Sometimes, we just leave the remainder as is, like 15 remainder 3, especially in simple math problems. Other times, we turn that remainder into a fraction like 3/5, which works great when we're dividing things like food or items. And then there are cases where we have to round up, adding 1 to the whole number, like when we need enough buses or tents for everyone, no exceptions. So, what do we do with the remainder? It all depends on the situation. Let's talk about decimals, what they really are and why they matter. A decimal shows parts of a whole, much like fractions do. The decimal point is key. It separates the whole number from the smaller parts. The places to focus on are tenths, hundredths, and thousandths. Think about money. A dime is 1/10 of a dollar, and a penny is 1/100th. This gives us a clear way to understand and work with numbers smaller than 1. When adding or subtracting decimals, lining things up is everything. First, always line up the decimal points vertically. That keeps your numbers in the right place. Next, fill any empty spaces with zeros to make sure your columns match perfectly. Finally, when you write your answer, drop the decimal point straight down into the final line. Following these steps makes your calculations neat and accurate every time. When multiplying decimals, we start by ignoring the decimal points entirely. Treat the numbers like whole numbers and multiply as usual. Next, we count how many decimal places there are in both numbers combined. Finally, we take that total and move the decimal point in our answer that many places to the left. For example, multiplying 0.2 by 0.03 means moving the decimal 3 places left, giving us 0.006. It's a simple, step-by-step process that keeps everything accurate. Let's break down the anatomy of a fraction. The numerator, or top number, tells us how many parts we actually have. The denominator, the bottom number, shows how many equal parts make up one whole. To simplify fractions, we divide both numbers by their greatest common factor. That's how we get the simplest form. And here's a vital concept. Every fractional part must be exactly equal in size. This is the foundation of understanding fractions. When adding or subtracting fractions, we can't just combine them if their denominators are different. The key is to find the least common multiple, or LCM, to create matching denominators. Once those match, we only add or subtract the numerators, while the denominator stays the same. For example, 1/4 plus 1/2 becomes 1/4 plus 2/4, which equals 3/4. This simple step makes working with fractions much easier. Let's talk about mixed numbers and improper fractions. A mixed number is a whole number right next to a proper fraction, like 2 1/3. To convert it, you multiply the whole number by the denominator, then add the numerator. On the other hand, an improper fraction has a numerator that's bigger than or equal to the denominator, like 7/3. That tells us the value is at least one whole or more. Both ways show numbers greater than 1, just in different forms. Multiplying fractions is surprisingly straightforward. No need to find common denominators. Here's the simple process. First, multiply the numerators straight across the top. Then, multiply the denominators straight across the bottom. Finally, simplify the fraction if you can. For example, 2/3 times 4/5 equals 8/15. It's a quick, direct way to multiply fractions without extra steps getting in the way. When solving math problems, the order in which we tackle operations matters a lot. We start with parentheses. Anything inside brackets gets solved first. Next come exponents like squares or powers. Then, multiplication and division moving left to right. Finally, addition and subtraction also from left to right. To keep it all straight, many of us use the memory phrase, "Please excuse my dear Aunt Sally." It's a handy way to remember the sequence and avoid mistakes. Let's dive into classifying polygons and triangles, starting with polygons. These are flat, two-dimensional shapes made entirely of straight lines that close back on themselves. When it comes to triangles, we can classify them by their sides. Equilateral triangles have 3 equal sides, isosceles have 2 equal sides, and scalene have none equal. We also classify triangles by their angles. Right triangles have one 90-degree angle, acute triangles have all angles less than 90 degrees, and obtuse triangles have one angle greater than 90 degrees. This is the foundation of geometry basics. Let's talk about filling up three-dimensional space. That's what volume measures. It's the total amount of space inside an object, and we always measure it in cubic units, like cubic centimeters or cubic inches. For a rectangular prism, the formula is simple: length times width times height. Imagine volume as how many tiny dice you could fit inside a tissue box, stacked neatly without gaps. This idea helps us explore and understand space in a very tangible way. Let's talk about mapping points precisely on a coordinate plane. The x-axis runs horizontally across the grid, that's the run. The y-axis goes straight up, that's the rise. Where they meet is the origin, at coordinate 0, 0. When we plot points, we use ordered pairs, written as x first, then y. Think of it like walking across the floor before taking the elevator up. This simple rule keeps everything clear and accurate. Math is everywhere in our daily lives, shaping how we build, play, spend, and cook. In architecture, we use exact measurements and formulas to design spaces that work. On the sports field, stats and percentages help us understand performance and strategy. When it comes to money, math keeps our budgets balanced and change precise. Even in the kitchen, fractions guide us to scale recipes just right. This is math in the real world, practical, powerful, and all around us. We've reached the finish line. You are a math champion. Remember, practice isn't just repetition, it's progress. Don't be afraid of mistakes. They show your brain is working hard and growing stronger. Now, if you have any questions, let's dive in and talk through them together. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.